We are working on the Connect 4 project from the YByte Python curriculum available at www.ybyte.in. Having built the functions to determine the lowest available row and all the open columns that are available on the board, now it's time to move forward and build the player's turn. Now remember, the player plays this game by clicking anywhere on the board. And as we have seen before, we can use the screen.onclick method for this purpose. We in fact already did this. The way this works is I specify a function that runs when the screen is clicked. This function must by definition take two arguments, which are x and y, which is basically the x and y location of where the mouse is being clicked. In fact, we have been seeing this. We explored this also when we were looking at the screen size and so on. So we know that this, sort of is all right, is already set up. However, we will now expand this function to make it like a complete, let's say, player turn. Now, the challenge, or let's say the problem statement right now, is that when we have a player clicking the screen, we need to figure out which column is the player, let's say, clicking. It's kind of like, like I said, if you think in the physical world, the player drops the coin in one of these columns and, just takes the coin on top and it drops down. Kind of what same thing what you're doing, except that from this click, we must figure out which column is the one that's coming in. Now, that's not too hard, really. Remember, this corner of the x value here is minus 350 and x value here is plus 350, and each of these circles are separated by 100. And in fact, we can use this fact. Essentially, what I can do is that I can just figure out, look, given that I know where the x is because I know that's where the click has happened, I can add 350 to that. So that's basically saying that, look, shift it all by 350 and then do a floor division by 100. Now, this may look a little bit complicated, but the way to understand this is, think about it. If let's say this was at 0, then this would be 100, this would be 200 and so on. So all I'm saying is that between 0 and 100, any x results in column 0. Between 100 and let's say 200, any x results in column 1, and so on and so forth. Since this is minus 350, we do a plus 350 over here. Think about it. It kind of makes sense. Let's just do this much and then we'll try to understand. We'll try to relate, let's say, the column, the click position and the columns. And by the way, in case the player clicks, let's say, too much to the left or too much to the right, I just assign the column to be 0, or let's say n calls minus 1, which in this case is 6. So that's the if conditions here. So I get to my code over here. Now I already have this function play, xy. Let's just print xy here for now. Like I said, I need to figure out which column I'm clicking. So, I just go and say, well, determine, say, the column. And the column can be determined quite easily by just saying call is equal to int, x plus 350 floor division 100. Now this has to be a floor division because we are just trying to find out the integer part of the division, the quotient that's coming out. So for example, if the division is 1.8, all we are interested in is 1 because that would be the column here, right? And we've discussed this already. Of course, if the column is, let's say, less than 0, so which means too much to the left, I just set the column to, let's say, 0. And if column is, say, greater than n calls, minus 1, then we just set the call to, let's say, to say n calls. Now, before moving further, I'll just print, let's say, column over here so that we can get a sense of what's going on. Remember, this function will run whenever I click anywhere on the screen because I have given screen.onclick play. And over here, I don't have to specify x and y. But when I define the function, I do have to specify the x and y. That's the nature of the, the syntax here. So when we run this piece of code, let me just draw the board here. Notice I can click, let's say, when I click, so let's say I click on the first column, you notice that my column number is 0. That's because my x was minus 301. So what did I do? I said, okay, let's do minus 301 plus 350, which is, say, approximately 50. Floor division by 100, and that gives me a 0. I click here, I get column as 1. Once again, you can convince yourself. I'm adding this to 350. So that's approximately plus 150. When I do a floor division by 100, I get 1. And likewise, so if I click here, that's column 2, column 3, column 4, column 5, column 6. Like I said, if I click too much to the left, that is treated as column 0. If I click too much to the right, it's also treated as column 7. I think this is a mistake. Let me just fix this. This has to be n calls minus 1. So because remember the columns are 0, 1, 2, 3, 4, 5, 6, which has to be n calls minus 1. So if I fix this, this should be okay now. We can just test this once again. When I, let's say, draw the board, if I go and click too much to the right, now it's correct. The column is 6 and that's what I want. Now, having determined the column, there are two things to be done. First, I must figure out if this column is, let's say, available. Is it open to be played? Because it's possible that the entire column has been played and the user goes and clicks again on that column. Now, that's not what we want. So we will, basically not do anything in that situation. We will first figure out if the column is available. If the column is available, we'll then figure out what is the lowest row in that column, and and once we do that, we will make that row as a player coin. So let's just see how we can do it. So notice I've figured out the column here. Maybe I'll remove this print so that it doesn't clutter the screen, and I will now go and say, okay, let me figure out if this, which are the columns available. So avail columns, I can use my function that I did earlier. So find open calls, let's say like this. So I figured out what are the open columns. Now if the call is in available columns, which means this particular column that the user has chosen is indeed available, then I must figure out the lowest row in this column. So I will figure out what's the lowest row. Again, that is available to me. That's, let's say, that function is available to me. I can just go and say, well, lowest row in the column, and that makes a lot of sense because I just figure out how, where should the coin ultimately, let's say, go and rest. Since that's a player coin, I just go and set this board, board, let's say available row, and say call to say 1. Now, having done this, I will then go and also draw the board. Now, notice I am doing all of this inside this if condition, basically, which it means that, if the column is not open, basically nothing will happen, which is logical. But if the column is indeed open, then the board will get drawn again. Now, let's see this working. When I go and click, let's say, on the 0th column, I click anywhere on the column. In fact, the coin appears right on the bottom because the lowest available row was indeed row number 5 in this case. Let's say I click on this column, the coin goes all the way down. It's as though the coin sort of fell down and reached here. If I go and click on this row again, this time round, the coin falls on top. The reason being the available row in this column is, in fact, now was, let's say, row number 4. In fact, if I keep doing this, let's say, so obviously in reality, the game would have gotten over. But notice now that I've done this, in fact, I'm clicking here, but nothing is happening. That's because this row is already taken up. If I click here, indeed, it will allow me to play. So, that's how the player turn goes. We will have to still complete it, but that's the raw structure of it. We will later on integrate this as part of the game loop. But for now, this is fine. I hope you found this useful. In general, if you think this way of learning works for you, where we are building activities to understand concepts, we see concepts in action, look at our website www.ybyte.in, because that is how we learn Python programming. Take care. Thank you so much. Bye bye.